Alright, so now let's talk about why to choose V-Ray. But first a little bit about myself. My name is Jonas Noell. I'm located in Germany and I'm a shading and lighting freelancer. And 𝐂𝐤𝐻 asked me to share some insights from my perspective on why to choose V-Ray in production. So I work in the industry since around 2009 and I started to work in visual effects, and there I worked mainly for a company called Pixelmondo. And back then we worked on a lot of movies and TV shows, and that's when I started to use V-Ray initially. And in the past couple of years, I transitioned to become a freelancer and now mainly work in the area of automotive and product rendering. So for me personally and professionally, I used V-Ray in pretty much all areas and used it in a wide amount of projects. And I found that V-Ray is very flexible and usable in pretty much all areas. So far, I've been using 3ds Max and V-Ray exclusively, but many are aware probably that 3ds Max development slowed down in the last couple of years. So I'm quite excited to see V-Ray now coming for Blender, because Blender has a vibrant community and there's lots of new developments. So I'm quite excited to see V-Ray now for Blender. I also run a YouTube tutorial channel since 2020, and there are many tutorials about V-Ray specifically, but recently also a lot about Blender and other software, and lots of general topics such as tone mapping and so on. So you can check this out if you're interested. So after this short introduction, let's come back to the initial question on why to choose V-Ray. And for me, it comes down to 3 key factors. So the first factor are the production ready and most of all artist friendly tools, which help to keep unnecessary complexity away from you and allows you to focus on what really matters, which is creating beautiful images. The second factor is V-Ray's flexibility. So any render engine nowadays is able to create photorealistic images, but only few of them are as flexible and controllable as V-Ray. And the third factor is that V-Ray follows all established industry standards, so it can seamlessly integrate in professional and established production pipelines without any issues. So let's first of all check out V-Ray's artist-friendly tools, and here I picked 4 different examples, and all of them focus on making important functions easily accessible to artists. So I picked the virtual frame buffer, the finite dome light, the LightMix, and we will check out how V-Ray's shading nodes work. So let's start with the virtual frame buffer, and for V-Ray artists, the virtual frame buffer is kind of a command center that brings together all important tools which are required for rendering and finalizing images. And I prepared a little presentation about it, which we're gonna check out now. So the virtual frame buffer for me in V-Ray is one of the best tools because it brings together a bunch of different tools which are very handy for rendering and analyzing your image, and even integrates an entire color correction, tone mapping, and even compositing workflow all in this one single tool. So here on the left-hand side, we have our render history, where we can always save our current rendering. Then it will be stored in this history list. And then you can check out previous renderings and see what changed or how your rendering here progressed. You can even compare 2 different renderings here with this sliding feature, and that can also be very handy. Now let's go back to our current rendering, and then here we have access to all of our render elements which we generated, so we can check out our global illumination, our reflection, refraction, subsurface scattering, and so on. And this really helps you to tackle down problems that you might have in your rendering, and also make sure that everything that you want to store for external compositing will also be saved correctly in your image. Now let's restart our rendering, because I want to show you these handy region rendering tools. So we can draw different regions here on our image. Let's say we only want to change the color of this light in here. You can easily just draw a region and then just change only this color to this kind of greenish color, or even something entirely different. Let me just undo this. Or we can even have these polygonal regions. So we can draw a quite complex shape here in our frame buffer directly. And then let's go in, for example, and change the color of his wing caps in here. So let me just shift here the hue. And then you can see only this part here is updated. Let's also undo this. And then also disable our regions for now. So up in here, we have all of our color corrections, tone mapping, compositing, and so on. And here we have our raw linear image. Then I just applied some tone mapping on here. I have a vignette, which I can position freely how I want. So I can just choose where I would like to have the vignette. I can change here the different size and so on. I have some exposure adjustments. We can go in and make the exposure brighter or darker, for example. And I also played here with the white balance to kind of make it this nighttime shot. So let's go down with the exposure. Let's go up a bit with the contrast and so on. Let's say we want to increase our overall saturation. I can easily just add a saturation node here on top. And this works kind of similar like in Photoshop. So you can easily tweak your image and get quite fast the result that you want to. You also have access to various kind of effects like those lens effects here, for example. And while all of this here looks quite simple and accessible, you can really go inside quite deeply and make some quite detailed adjustments. Let's say, for example, we want to go in and change here our wing caps. Let's say we want to increase the brightness of those. So let's add a new exposure adjustment and let's make some adjustments in here. But we only want to have those adjustments here on those wing caps. We can then go in and add a crypto matte and then just pick here our two different wing caps and then basically just have adjustments here localized on our image. So you can see you can do some quite detailed adjustments here directly in the frame buffer, and you can basically finalize your entire image directly here in this frame buffer. So after discovering the virtual frame buffer, we will now check out the finite dome light, and this serves as an example to simplify HDRI lighting in V-Ray. So whenever using HDRI environment lighting, it's sometimes a bit difficult to really integrate your 3D objects into it, because as you can see, the HDRI environment is always infinitely far away. I can zoom out as far as I want, and the only thing that's changing in size here is my 3D geometry. Everything else is infinitely far away. And V-Ray offers a very simple solution for this problem by just turning your dome light here into a finite dome. Once you do this, you can see that your HDRI environment will be projected on a geometry which has a physical scale in the scene. And this way, your object is not really floating here in space anymore, and it's neatly integrated directly into the environment. You can then allow a separate plane that acts as a shadow catcher. And like this way, you can get nice shadow interaction and seamlessly integrate any 3D object directly into an HDRI environment with just a click of a button. So next up, we're going to check out another nice artist-friendly tool, which is LightMix. And this serves as an example to give lighting and shading artists a tool at hand, which normally requires much more complex compositing workflow, so that you can easily control your image in real time without having to re-render anything. So using LightMix, you can easily tweak your scene lights while or after the rendering in real time. For this, you just enable here the LightMix option and then just start a rendering. So this scene took quite a while to render because of the sampling and the environment fog. And normally if I would want to change now my lights and so on, I would need to re-render everything again. It would cost me a lot of time. But using LightMix here, I can go in and tweak all of the lights here in real time. For example, here I have the light for my flying saucer. I can turn that on or off. I can, for example, boost the brightness here in the scene. I can make it less strong. Or I can change the color here, make it more warm, more cold, and so on. And you can then really tweak how you would want your lights to look like. Here, for example, I think the light color is not really fitting to the window color, so I would just identify which light is responsible. So that would be this one in here. I can then boost the brightness and I can change the color, let's say to this more yellowy color. Let's make it slightly more warm. And I think like this now, it looks much more fitting to the window color. So as you saw, using LightMix just requires a push of one button, and then you have access to tweak all your lights here separately and be much more flexible and fast to achieve your end results. Finally, let's check out shading nodes, which work a little bit different in V-Ray compared to cycles because they group various functions together in easily accessible node setups. And like this way, overall, in my opinion, at least simplifies setups a lot. So working in the shader editor, there's a bit of a difference on how V-Ray and cycles approach the same problem. Here we have a very simple problem. You can see we have this repeating texture map, and we just want to randomize the rotation here of this texture map so that we don't really have this repeating pattern anymore. So now we are in cycles, and in cycles the approach is to basically just pipe a bunch of different nodes here together, because each of those nodes here only does one very small function. So you have to pipe a lot of them together, use quite a bit of brain juice to build a more complex setup like this in here. And then once you're finished and you tested everything, you can then use this here. And now we get the result that we want. Not exactly, because it seems here some of those textures are still repeating, but in most places here we have now this rotating pattern, and that solves this problem. But as said, the complex setup here is maybe something that scares some artists away, because oftentimes you don't really want to spend a lot of time or effort here to figure out some complicated math and so on to just solve a very, very simple problem. So now we're rendering with V-Ray, and we are confronted with the exact same problem, but V-Ray uses a different kind of approach to solve these kind of issues, and it groups these kind of reoccurring tasks into some ready-made artist-friendly tools. So in our case here, we would need to use the UVW randomizer tool, and we just put this here between our mapping and our texture. You can see something is happening already, and there's very few options in here because all of the options are kind of hidden in the N panel. So in V-Ray, with a lot of those nodes here, you have to use the N panel in order to tweak all of the different settings. So in our case here, we want to use the stochastic tiling. That means we have randomizations for each UV tile. That's what we want in this case. You can see we have some tile blending mode here where we can blend between different tiles. In our case, we don't really need that. We want to have this here set to 0. And now we just need to take care about our offset and our rotation. So we don't want to freely rotate our texture on every UV tile. We want to do that in steps. So in this case, we will use 4 steps. We also don't want to have completely random U and V offsets. So let's use 3 steps here for the U offset and 3 steps for the V offset. And now you can see we have exactly, or an even better result that we had in cycles by just piping a lot of different nodes together. And it just took us a few seconds to reach this result. So again, this was just a simple example to demonstrate, but it's important to understand these two different philosophies. So V-Ray has a lot of these kind of pre-built artist-friendly tools here already set up, and it doesn't require the user to really think about some complex math problems and so on, just to achieve a simple result. So now let's talk about flexibility, and nowadays pretty much any renderer is able to generate photorealistic results, but V-Ray especially focuses on making everything still tweakable and adjustable, and this includes the ability to break physics in order to achieve a certain kind of effect or desired result. So here I also picked 2 different examples, and let's first of all check out V-Ray's lights, because they serve as an example of a, in general, very basic tool, which in V-Ray has a huge amount of functions and customizations available. So I also prepared a little demo that shows you all of this. So in V-Ray, I really like how lights are integrated. I want to show you the core concepts in this simple scene. So here we have 2 different light sources. We have this light source here at our monitor, which is just responsible for having some nice blue fill light here on our keyboard. And we have the light source here in our desk lamp. Let me first show you the visibility option. So you easily have the option to make the light source invisible. So in case of this desk lamp, that's maybe not really what I want, because I want to see my light source here. But let's say for the monitor, I don't want to see the light source, because as you can see, if I enable this, then I can't really see the content on my monitor anymore. So in this case, I just want to have this here invisible. So now if I select here this desk lamp again, I want to show you that we have access on all of the different aspects here of the light. For example, we can say that we don't want to cast any diffuse lighting in our scene. And now you can see it's not really illuminating our scene, but we can still see the specular highlights. And as the scene here uses some environment fog, it's also affecting here the fog, as you can see. If we want to disable the specular highlights as well, we can easily do that. And now we only affect our fog. We can also disable this. And now we only have the light source here visible, but it's not really affecting anything in our scene, which also can be quite handy sometimes. So now let's enable this again. And instead of just turning it off and on, you also have the options to tweak the exact amount. So let's say we only want to have very little diffuse contribution. So now you can see our diffuse contribution here is quite weak, but we still get those specular highlights. Let's say we want to boost those specular highlights here a lot. And you can see that those specular highlights now are much stronger, and we just kept the same diffuse contribution. So you can basically separate all of the different aspects of your light. Let's say we also want to increase here our atmospheric, so our fog contribution. Let's boost this. And you can see that now it affects the fog much stronger, and that without affecting here our diffuse contribution. So this makes working with those lights here very flexible. If you want to stay physically accurate, of course, all of those values here should be set to 1. But in case you need it, you have the option to easily break physical rules and then just get exactly the type of result that you want. So another great way to break physical rules and this way increase flexibility is to use those decay options in here. So let's say I want to boost my light source here a lot, and I like the brightness here in this part, but I don't like how much it's affecting now my entire scene. You can see it's now reaching the chair. Then you can use the decay options, and let's enable this. And I already set here those settings earlier. And now the light is basically bright in this part, but it's not really reaching very far in my scene anymore. And you can then just tweak this here according to your liking. You can see that now it reaches the chair a little bit. Let's make this a bit less. And without affecting here my core brightness, I can define exactly how far this light should reach in my scene. What we also can do, of course, is to include or exclude objects from our light source. So here, let's pick those sticky nodes in here. And now you can see that those sticky nodes here are removed from our illumination, and they also don't cast a shadow anymore. If you want to still see a shadow, you can just remove them from the illumination. So you can see now they don't get bright anymore, but they're still casting a shadow from the light. And we can also just remove the shadow casting so that basically here our sticky nodes, they become bright, but they don't cast a shadow anymore. So you have lots of different options here, and this can be very handy in a lot of situations. So next up, we're gonna check out various types of overrides, and they are really great because they enable you to break physics. And like this way, you can address easily clients' feedback or achieve results in rendering directly that normally require additional compositing. So overrides are also a way to bend physics and get exactly the kind of result that you want. And in V-Ray, that's implemented in various levels. Let's check this out on the shader level first. So for this, let's add a V-Ray override material. Just put that in our node graph for now. And here we have the shader of this monitor, and the override material now gives us access on how it should affect our global illumination, how it should affect our reflections, refractions, shadows, and so on. So in order to use this, we need to put it in our node graph here between our existing shader and the material output. And now we can duplicate this shader, also connect our texture again, and connect this in our reflect material. At the moment, nothing changes because we need to enable this here. So let's enable this. And now we separated our reflections here, and we can define these now completely by our separate material in here. So if I want to, I can disable my reflections by just putting our multiplier here to 0, or we can increase the reflections. And you can see that now our monitor reflects much stronger in here. Now let's go in and add a simple color correction inside. And then we can change, for example, here the hue. And we have our monitor now reflecting in an entirely different color. So those are overrides on the shader level. Apart from that, there's also overrides on the object level. So let's select the laptop here. And then in the visibility options, for example, we can then define here our laptop to not be visible in the reflections, and then it simply disappears in all of the reflections in our scene. So apart from those basic options, there's also these include and exclude options, and this allows something like reflection or refraction linking. So let's select this cube up here, and then in the visibility options, for example, let's go to the include tab, reflection objects, and then let's exclude here our laptop. And now you can see our laptop still shows up in the reflection of this object, but is excluded from the reflection of this cube up here. So this is also a great option. It's also something that I haven't really seen in other renderers. And now finally, let's talk about what makes V-Ray industry standard. And in production, it's not only important what happens during the rendering itself, but equally so what happens after the rendering. And that's normally where the compositing starts. And here V-Ray integrates perfectly in established production pipelines. So now let's discover this by focusing on industry standard color spaces, render layers, and also the ability to bring over tweaks from V-Ray directly to external compositing software using LUT files. If you work in a professional production pipeline, once your rendering is finished, it will then be handed over to compositing. For that, it's important that it follows certain kind of standards. So V-Ray, in terms of color management, supports sRGB and, very important, ACES-CG. And ACES is the color space that's now used widely in the industry. Additionally, it's important to generate all of the required and demanded render elements here, GI, reflections, and so on. And here V-Ray has a huge amount of render elements available. Let me just expand all of those different layers in here. And you can see you really have a huge range of different render passes which you can export. And those will fulfill all of the needs that compositing artists may have. So for this simple scene, I only require those elements, but a lot more as said are available. So this scene here uses now ACES-CG for rendering. We can also load our OCRO configuration file directly here into the frame buffer and then see the finished result. And what I also did was to add here some additional adjustments on top of the image because I felt like the base rendering here maybe was a bit too dark and I just wanted to make it a little bit more warm. So I just added some additional adjustments here directly in the frame buffer. And all of those adjustments we can easily save out as a LUT file, which then also can be brought in some external software to just match exactly the same result we have in here. We will then use OpenEXR to export our linear render elements and store them all in a single EXR file that we can then pass on to compositing. So now, for example, in the very widely used compositing software Nuke, we can easily load our exported linear EXR. We can use ACES, same color space as in V-Ray. We can then split up our EXR into the different channels, which we then recombine here. And also apply the lookup table that we exported from V-Ray earlier. And just like this, we get exactly the same result that we had in the V-Ray frame buffer. And now we are ready to do additional adjustments here on our finished image. So since V-Ray follows all of those industry standards, it's then very easy to integrate V-Ray into a whole production pipeline. And like this, seamlessly transfer your renderings to different departments. So now coming back to the original question on why to use V-Ray. So for me, it's the combination out of these artist-friendly tools, the flexibility to get exactly the kind of result that I want, and it also follows all industry standards, so it easily integrates into any given production pipeline. So this finishes my presentation, and make sure if you have questions to address them in the end, and I will be happy to answer them.